Hi friends, welcome to Unit R, Day 6. This concept is mostly about radical and rational exponents. One of the big things that we're going to see in this section is how we can convert radicals and rational exponents, and that they are the same. One of the things that I want to note on this section is the formatting is a little bit different to fit the table on here, so just bear with me as it's a little bit spread out and the objectives are a little bit squished. But jumping right in, the properties. Square root. If I take the square root of a number, a lot of students miss this. But if I take the square root of, say, let's take the square root of a squared. Now, a is the absolute value of that result. So if I take the square root of a squared, I get the absolute value of a. And that works for any even roots that we need to include that absolute value when it's a variable. An example of this also, like if I take the square root of 144, we know that that is 12. That is the value 12. But if I take the square root of x squared, I get the absolute value of x. Cubed root. So if I take the cubed root, so the cubed root of n cubed, then we get n. The cubed root of n cubed is n. Similarly, if I take the cubed root of 8, I get 2. And if I take the cubed root of x cubed, I get x. So notice on the cubed roots, or the odd roots, we're not concerned with that part. So when we talk about nth root, we're going to have two cases. We're going to have like an even case, and then also an odd case. So if I have an even case, say we have n, the nth root of a to the n, then what we have is we need to have the absolute value of a. But if it's odd, so this is even, this is odd. If it's odd and we take the nth root of a to the n, then it's just a. So that's if the n value is odd. So n is even, n is odd. We have two examples here. Some additional examples. If I take the fourth root of 16, that gives me 2. If I take the fourth root of x to the fourth, I get the absolute value of x. And if I take the fifth root of x to the fifth, and that just gives me x. So one of the things that we can do with radicals and rational exponents is kind of interchange them. They are the same. So when we have rational exponents, if I have a power, if I have a to the m over n power, so n's the numerator, n's the denominator, that's the same thing as the nth root of a to the m power. So those are equivalent. Those are exactly the same thing. So just to kind of notate that, the denominator is the root, and the numerator is the power when you're converting from a radical or the other way around. So again, you can convert these both directions. They mean the same thing. So if I have, for example, let's do 27 to the 4/3 power. So another way of thinking about that is the cubed root of 27 to the 4th power. Those are mathematically equivalent. Now, this is not reduced down completely, because I could take 27, and that's 3 cubed. So I have the cubed root of 3 cubed, all raised to the 4th power. And then I can use properties to actually eliminate the 3 cubed and the 3 to the 4th. So the cubed root of 3 cubed, all raised to the 4th power. So the cubed root of something cubed is just itself. So now we're left with 3 to the 4th power, which is 81. And then the next one, property, the product property of radicals. So what we can do is if we have things that are underneath the same radical, the same root, we can kind of expand them out. An idea behind that. So if I have the nth root of a times b, that's the same thing as the nth root of a times the nth root of b. And generally what we do is we're actually usually do this the other way. We take something that's the nth root of a times the nth root of b, and then we combine them under the same radical so that we can simplify them. For example, if I have the square root of 16x squared, I can do the square root of 16 times the square root of x squared. Square root of 16 is 4, and the square root of x squared is the absolute value of x, whatever x is. We have to include the absolute value of x here because if x is -3 here, we don't actually resolve it till to the end, then what we end up with is -3 times 4. That's why we're saying it's the absolute value of x. There's a kind of real-life example of that. The quotient property of radicals, similar, but now we're saying if I have the nth root of a divided by b, the same as the nth root of a divided by the nth root of b. We'll also talk about how we rationalize the denominator no matter what. No matter what any other teacher tells you, we always rationalize the denominator, always. Example of this, if I have the cubed root of 27/8, what you can do is you can take the cubed root of 27 divided by the cubed root of 8. We can simplify both of these. Cubed root of 27 is 3, the cubed root of 8 is 2, so we end up with 3/2. And just to denote, a radical expression is in simplest form when the radicand has no perfect nth root factors, the radicand contains no fractions, and no radicals occur in the denominator. So those are the big three. Join me in the next video where we go over some examples and evaluate radical expressions.